Today's lecture, we are going to take you to the very bottom of the deep, deep ocean. Professor Kelley recently retired from the University of Hawaii after 2.5 decades, where he served as graduate research faculty for the Department of Oceanography and a program biologist for the Hawaii's Undersea Research Laboratory. After moving to Port Townsend just a little over a year ago, he continues to serve as affiliate faculty at University of Hawaii, where his core responsibilities include identification of deep water animals recorded during submersibles and remotely operated vehicles operations, extraction and archiving data from deep water dives, and creating online deep water animal identification guides. Between 1997 and 2013, Dr. Kelley participated in numerous Pisces 4 and Pisces 5 submersible dives off of the University of Hawaii ships, and I'm not going to be able to pronounce this, one of their spectacular ships, the KOK apparently, working at depths of between 200 and 2,000 meters. From 2014 to 2018, he led research cruises on the Nautilus Ocean Exploration Trust around Hawaii and elsewhere in the Pacific that involved mapping the seafloor with multiple beams, sonar conducting hundreds of ROV deep dives at around 6,000 meters. So when I said the very bottom of the ocean, well, Chris will be able to tell us if that is the very bottom of the ocean or if it goes further. Without further ado, I am so pleased to present now hometown native, Port Townsendite, Dr. Chris Kelley.
Okay, thank you very much, Janine. And I'm just going to check to make sure that everybody can see my screen. Hopefully that's right. Okay. So thank you very much, Janine and Diane and Gabriella, for inviting me to give a lecture today. I'm delighted to be here. It's one of my favorite things to talk about, the deep sea. And also I hope you and I will have a really nice break from all the politics for the past few weeks or months, if you will. Anyway, I'd like to take you into deeper waters and explore the Earth's largest yet least understood biome. And for some reason, I've got some things on the screen here. Let me see if I can get rid of these. Oops, sorry. All right, as you can see, I'm a little bit new to Zoom. I've used a bunch of other things here, but I'm not as familiar with Zoom. In any case, here we go. So the deep sea floor covers over 2/3 of our planet's surface. And this is the one picture I think that really depicts that. And one of the things I've mentioned in other types of lectures is that if you don't know anything about the deep sea, then you really don't know much about your planet, because as you can see by this particular image, the deep sea is far greater than a lot of the land that we live on and we inhabit. Why is it the least understood biome? Because it's technically challenging to explore it. It's as challenging as space is. It just has different problems that need to be overcome. And one of the biggest problems is pressure. So at each depth interval of 1,000 meters, the pressure increases by close to 1,500 pounds per square inch. So when you get to the bottom of the Mariana Trench, which is the deepest place in the oceans, and that's 11,000 meters deep, the pressure is almost 8 tons per square inch. And so you have to involve a great deal of technology in order to get down there and to explore the depths at the bottom of the sea. I'm just going to tell you a little bit about the deep sea environment here. A lot of this people know. It's very, very dark. as you descend from the surface and you start going deeper, the light spectrum or the wavelengths of light are attenuated, with blue around the 400, 500 nanometer range are the last to go. And then once you get down to about 400 meters in tropical water, then all the blue is gone as well. And so you're entering what we refer to as the aphotic zone. And that's sort of what I consider to be a sort of a boundary of where the deep sea begins. Some people consider when there's still some ambient downwelling light to be the twilight zone. And then below that, you get into the deep sea as well. So this is another thing. This is just temperature and oxygen. And the thing I want to bring to your attention is temperature, as you might expect, drops. And it sort of levels out very close to freezing, around 1 to 2 degrees centigrade, and just sort of stays there as you go deeper and deeper. But oxygen does something really weird. And oxygen starts out at the surface relatively high, then it drops off fairly rapidly, and then it gets to a particular depth, which is often referred to as the oxygen minimum zone. And it sort of bottoms out at this depth, and then it starts going back up again. And this is some Hawaii data right here, where the OMZ, it's not an actual OMZ, it's the insular or the island equivalent of an oxygen minimum zone, is occurring around 700 meters, but it all depends upon where you are. It can be shallower, it can be deeper than that. Anyway, I'm not going to go into why that occurs. It's pretty complicated, and I've heard a couple different explanations for it, but just the one thing I want to note is that a lot of us who are studying deep sea biology are very interested in oxygen because of these changes, and we think it could be having a major impact on the communities in deep water. And then I wanted to bring this up. This is bottom currents. So there's a lot of things that are responsible for current in the deep sea. There's a thermohaline type of phenomena that goes on as well. But the one thing I wanted to bring up is tidal currents. And this is just some data. And by the way, I'm not going to show you that many graphs, so don't get all anxious here. This is some data that Dr. Frank Parrish took off of Hawaii, off the island of Oahu, at this place that was about 400 meters deep, so right at the top of the deep sea zone. And this shows you the intensity of the current is very regular in sort of a north-south direction here, and the red being the highest intensity current. And then he mapped this against the tidal height change in that particular area. And there's a very, very good correlation to the tidal heights that are occurring near the surface. And so what this means is that the tides are essentially affecting the deep sea. You know, we kind of think about them mostly with respect to the beach and shallow water. And Nan Evans, on her show Nature Now, she interviewed an author, Jonathan White, of a book about tides, The Tides, the Science and Spirit of the Ocean. And he was also talking in that interview about the fact that these tides are sort of a form of clock. And we also sort of think that this could be a way in which deep sea animals are telling time and telling seasons, is by tidal changes, which they can detect. As you can imagine, you're not going to get many temperature changes. You're not getting changes in photoperiod and things like that in the deep sea. So current flow, as it accelerates and decelerates, could be a way that they can keep track of time. So why should we explore the deep sea? Well, if that argument that it covers 70% of the Earth's surface doesn't convince you, I'm going to give you some other reasons here. NASA, believe it or not, is very interested in the deep sea. And the reason for this is there are some people there that believe that if we do eventually find life on another planet or another moon, it's very likely going to be aquatic life. And there are 3 moons in particular here in our own solar system, Enceladus, Europa, and Ganymede, which they've hypothesized could have subsurface oceans beneath their ice layer. And the oceans are kept liquid by the volcanic activity of the center of the moons themselves. And so because of that, they're speculating that the environment in these oceans could be very similar to the deep sea. And so they're sort of looking at deep sea environment and deep sea animals as possibly a potential window in what we might expect on other planets. So what do some of these creatures look like? Well, I'm going to show you some today. But here's another reason why we want to study it, is that the deep sea has by far the largest number of undiscovered species, at least in larger types of fauna, not necessarily in microbial, very small organisms. But here's just a few pictures of some of the animals which we have not collected and we have not yet identified yet. And I'm using this sort of picture format because this is a format that you can find in the Ocean Explorer, NOAA facility and animal guide, which you can download yourself. You can go onto the guide, there's already 5,000 pictures of deep sea animals, and you can right click and grab the picture for yourself. But in any case, these are all going to be new species, I'm pretty sure. And I've never seen any of these things before or anything like them. And so every time we do a deep water dive, we have a very good chance of seeing something that nobody has ever seen before. Another reason, and I don't expect you to necessarily be able to read all of this, but there's a whole group of people, Shirley Pomponi down in Florida is one of them, that is very, very interested in the potential for the discovery of new drugs and chemicals in the deep sea. And here's a few of them here, some potential anti-cancer agents and some painkillers and some wound healing and some other things. And there's a bunch of articles about the search for new drugs in the deep sea. And given that there's so few animals that really know that are known from the deep sea, there's huge potential down here for finding something that could be very, very useful to us. And this is one of my own pet reasons, if you will, and that is that the deep sea floor in various locations is covered with mineral-rich precipitates that occur in two forms. One of them is this right here, which is a manganese crust is what it's referred to. It's actually a coating over all exposed rocks, and here's the coating itself over some of the rock here. And it coats everything that's exposed that doesn't have a lot of sediment cover. And then you also get manganese incrustations in the form of nodules that, it's sort of like a pearl, I guess. There's a little piece of shell and the manganese and some of the other minerals that precipitate sort of collecting on that shell, and then they grow and grow and grow until they form these nodules. What's so important about this is that this is a huge resource of commercially valuable minerals, because in these crusts and in these nodules, there's a very high percentage of iron, cobalt, there's rare earth elements, there's copper, there's all types of potentially valuable minerals here. And at some point in the future, we're going to run out of all of the minerals from terrestrial sources on land, maybe probably not in our lifetimes, but it's going to happen. And so right now there's a great deal of interest in developing the technology to mine the deep sea. Now, when that occurs, which I think is almost inevitable, then basically they're going to have a ship, they're going to have some type of a vehicle down here. It's either going to be scooping up nodules or it's going to be scraping off the surface of those crusts. And when that happens, whatever animals are living amongst those nodules or living on that crust are going to be destroyed. It's a little bit like strip mining, if you will. And then the machine itself, by all of the activity, is going to create a toxic sediment cloud. And by toxic, I mean one of the other components of manganese crust is arsenic, if you will. And then they're going to pump this material up onto the ship, and then they have to release some of the water back in, which is still going to have some of this material in it. And so there's potentially going to be some very dramatic impacts to mining. And so what we're trying to do is we're trying to learn something about the deep sea before it actually happens at a commercial scale. Okay, so there's a bunch of reasons why everybody should be interested in the deep sea. And now I want to tell you a little bit about how we go about exploring it. And there's a bunch of ways that it's done, but I'm going to talk about two basic technologies. And these are mapping with a type of sonar that's called multi-beam sonar, and also direct observations via occupied or unoccupied vehicles. So let's take a look at mapping first. Multi-beam sonar, what that means is those of you who go out fishing and have fish finders, you know, a fish finder is basically a single beam sonar, sends a pulse to the bottom, reflected back up to your boat, and then the computer inside your fish finder interprets it to tell you what the character of the bottom is and what the depth is on it as well. Now imagine that you've got a system that has 150 of those beams that are all separated out by about a 1/2 to a 1 degree arc that are going out from underneath the boat. And that's what multi-beam is. And what that allows you to do is it allows you to map the seafloor in large swaths. And the technology is so well developed that you can actually control the system with just a single operator here that is to collect the data. And I'll just show you a little animation I borrowed from NOAA, showing you how it sort of works. So as the ship just goes along, it's essentially just mowing the lawn. When it finishes this one stretch, it'll turn around and go in the opposite direction, and just like mowing the lawn, until it's got all of the seafloor that it wanted to map completely covered. Okay, so all right, I think of mapping as a form of exploration, but why do we map? Well, this gives you an idea. If you were to go on to Google Earth and you were to look at some place in the ocean and really zoom in on some of the imagery on Google Earth in an area which has not been mapped by multi-beam sonar, this is what you're likely to see, sort of these fuzzy mounds here, so that we know there's something here. This is probably a seamount, and this could actually be a seamount that with maybe a crater right here in the center of it, right? But we don't know because the image is not very clear. This comes from satellite altimetry data. And when you map it with multi-beam sonar, this is what you get. So you can see that it's not just a single seamount. In fact, this is a little seamount right here that's a real small volcano that's pretty low to the abyssal plain right here. It never got to the surface. It still has a little cone, sort of a pinnacle type of shape. And then this one is a little bit larger volcano. This is probably, you could probably consider this to be perhaps a single seamount, but this part never really got to the surface either. But this part did get to the surface and was very likely an island. And how do we know that? Because typically when you have a volcano going off on the seafloor and there's so much activity that, and it goes on for long enough where it actually can rise up 4,000 plus meters off of the seafloor, then it can form an island like this over here. And as the volcanic activity diminishes, then it starts to sink due to the weight on the Earth's crust of the volcano itself. Reefs build up around it. The island itself starts to erode. And what this ultimately does is it tends to sort of cut off the top of the volcano and create a flat top. And initially, this is referred to as an atoll when it's still at the surface. But then when it drops below the surface and the corals die because it gets too deep, then it becomes what they call a bank down to about 200 meters depth. And once it keeps dropping down to the seafloor, less than 200 meters from the surface, it's referred to as a guillot, which is to honor a French oceanographer. There's a lot of guillots in the Pacific, and they're really fascinating, partially because they're going to be the first type of feature that's targeted by the mining industry. Okay, so memorable discoveries from mapping. So what I'm going to do is just give you a few of my favorite examples of what I consider things that we found out by exploring via mapping. And the first couple of examples are coming from the Hawaiian Islands. And this is definitely one of my favorites. And this used to be known as Bank 9, this whole feature, before it was mapped, because we had no idea. The summit here is about 80 meters from the surface here, so it's a bank. And it's now named Schmidt Seamount, named after Eric and Wendy Schmidt, who actually set up the Schmidt Ocean Institute, and which operates the ship Falkor, and it was the Falkor that this mapping was done off of back in 2014. And in any case, what's so unique about this seamount is that it's two completely separate volcanoes, and these volcanoes went off 40 million years difference in time. So this was the first volcano that went off, and this is a Cretaceous volcano that was an island at one point near the surface. And now it's down around 1,000, I think 200 meters deep, the summit of this thing. And because of the way the Pacific plate moved, when the Hawaiian Islands started being created millions of years later, then it intersected with these Cretaceous features. And so a Hawaiian volcano erupted right to the north of this. And that's what this part of it is. And they're sort of joined right here at the hip. So this seamount now is a composite seamount, which is really, really rare, at least now. I suspect we're going to find more of this type of thing in the future. But anyway, it was so unique that it was worth naming this feature after the Schmitz and their generosity. Okay, here's another thing. This was mapped by one of my colleagues, two of my colleagues, Joyce Miller and John Smith, out on one of the University of Hawaii ships. And some of this data also comes from the Okeanos Explorer and from the Falkor. But the thing I want to draw your attention to first is that there's this huge crater that's down here on the southeast side of Maro Atoll, which is up in the northwestern Hawaiian Islands. And here's a better close-up picture of it. This crater is 5 kilometers across, and the bottom of it is 3,000 meters deep. And this upper part of this rim is 2,200 meters tall. So the crater itself is 800 meters deep. Okay, so it's this huge feature. And when we saw this, we did do a dive in it to collect some rocks and see what it looked like to try to figure it out, because there were 3 possibilities. One of which is that it's a meteor strike. This was probably very, very near the surface, this whole area at one point in the past. The second possibility is this was an explosive eruption, perhaps because of water getting inside the actual volcano in the magma chamber or something. And this would be making it somewhat similar to Diamond Head on the island of Oahu. And the third possibility is this is just a collapsed magma chamber of a gigantic volcano. The jury's still out. As far as I know, the rocks have not been analyzed completely yet. But we would never have known this rather unique feature was down here if it wasn't for mapping. The other thing I wanted to point out is Maro Reef is coming apart. So one thing you can see here is this terrace of old drowned reef is just coming apart. So this is actually landslide deposits that have slid off in this direction. Same thing here. This whole part of this atoll is just breaking off and falling out. And right here, these are the landslide deposits out of here. This is coming off of this side, so it's disintegrating very slowly. Okay, and then another one of my all-time favorites here is this is the Mariana Trench, which everybody knows about. And that's this very deep blue line that's running around like here. Here are the Mariana Islands on what's referred to as the volcanic arc. This is what's called the fore-arc area, and that's the back arc area. And this is the Pacific Plate. And this is the big, huge plate in the center of the Pacific that the Hawaiian Islands are located on. And the way it works is that the Pacific Plate is ramming up against this plate. So here's one plate, and here's another tectonic plate. This is the Philippine Sea Plate. And they're ramming up against each other, and the Pacific Plate is losing. The Pacific Plate is being subducted underneath the Philippine Plate. And so this is what it looks like. It's going down like this, and it's getting subducted underneath the Philippine Plate right here. And the trench is right there at the subduction zone, right along there. And that's what creates this super deep trench that's deeper than the normal seafloor in the Pacific. Okay, so we know what the trench is, but what I'm going to do is I'm going to show you another view of just this area right here where these 3 seamounts on the Pacific Plate are very close to being subducted into the trench. And here it is. It's sort of a 3D view, so we're looking kind of north along here. And this is an image that I created when trying to find a dive site when we were off of the Marianas there. And here's the Mariana Trench, and it's hard to see here, but this is right along this edge, going right along here. And there's the Philippine Plate and the fore-arc of the Mariana, and the Mariana Islands are back here. And then here are seamounts on the Pacific Plate. So this is all Pacific Plate. Here's the Philippine Sea Plate. And the one thing I noticed from this particular image is the Pacific Plate just isn't bending like a rubber structure. It's actually fracturing as it's bending down to go underneath the Philippine Sea Plate. And you can see these fracture lines running across the seafloor. But what's so unique is some of these fractures went right across a couple of these seamounts, this one here and this one here, although this is too far away to see, and some it didn't. But what this gave me the idea to do is that I realized that this could give us a look at the inside of a very, very old seamount, because this is a fracture area that's probably uplifted when the whole thing fractured. And it was about, I think, 100 to 200 meters high. And you never would be able to see the inside of one of these seamounts in any other circumstances. And this is 5,000 meters down at this particular point. And what we were expecting is we thought that this could be a Cretaceous lagoon, because this seamount's probably about 100 million years old. So we dove on it with the Okeanos Explorer's ROV, the Deep Discoverer, in 2016. And I'm getting ahead of the game a little bit, but I'll show you what we found. This is what it looked like, that whole ledge here. And it was this incredible deep white type of substrate, which had banding across it like this. And if you look closely in these bands, you find fossils in the bands. And yes, indeed, this was a 100 million year old lagoon that is now down at 5,000 meters depth. And these fossils are Cretaceous fossils that are now in the Smithsonian. And the reason this is all white is because the Cretaceous is named for these white shells of microscopic organisms that were very abundant in the Cretaceous period. And Creta is referring to chalk, if you will. And those of you who know the White Cliffs of Dover, those cliffs are Cretaceous lagoonal cliffs as well. And so we would never have been able to see this without this incredible phenomenon occurring that was all discovered via mapping. Okay, how about Washington State? Well, let's take a look at Washington State. Here we are in Port Townsend, and here's the Salish Sea, of course, here in Puget Sound. And one thing you'll note is that a lot of this is orange and yellow, and that's because the Salish Sea only in a few places may get to about 300 meters deep, but that's about it through most of it. In fact, to get to the real deep sea, I guess you would consider it 400 meters and below, then you got to go out about 25 miles off the coast of Washington. But when you get out here, then there's some interesting canyons, in particular the Quinault Canyon. And I'll show you a little bit of video footage a little bit later on from a dive that took place in this canyon just literally a few weeks ago as well. And if you go further out, I'm not showing you more outside here, you go way out, then you can see the Cascadia margin where the Juan de Fuca plate is subducting under the North American plate that we're living on right now too. And there's some fascinating geology here. But the main point is that the Salish Sea doesn't really have deep sea the way we would normally think of it. Okay, so let's switch over to direct observations. So as I mentioned, there's a variety of different ways that you can study and get observations in the deep sea, but I want to focus on two in particular, and really mostly this one, the ROVs. HOVs are human-occupied vehicles, and this is pretty much the only slide I'm going to show about this, to show you that these are the submarines, that the type of submarines that we go down into in person. And so when we're talking about a human-occupied vehicle, that's it. Somebody gets inside of this thing and is actually down there at 2,000 meters, looking out port windows. This is the size of the window here, and you have videos, and you have all types of instruments and other types of things going on here as well. But also, it looks like it's a big space, but actually it's a 7-foot sphere right here. So there are 3 of us that are right in this tiny little sphere. We get in through this way and get out through this way. And it's a pretty wild experience, and I'm going to leave human-occupied vehicles for some other day, because there's a lot of good stories about them. But in any case, I want to switch our attention over to remotely operated vehicles. And this is a cartoon I got from the NOAA Office of Ocean Exploration showing what's referred to as a 2-body ROV, which I consider to be the state of the art in ROVs. Basically, here's the main vehicle. In the case of the Okeanos Explorer, this is the Deep Discoverer, and this is a camera sled. This is called the Sirius camera sled, and then here's the ship, the Okeanos Explorer. Now, why do I consider this to be state of the art? Well, for one thing, this is the camera sled. This is the actual one that's on the ship. There's the Okeanos Explorer, that's the Sirius and the Deep Discoverer, and this photograph is being taken by the camera sled up here of the main vehicle when it's near the bottom. And it's a very unique design that allows you to really get a sense of place where the vehicles are exploring, but also the camera sled can keep this vehicle out of trouble because it can see what the features are in topography and make sure the cables that are connected to it don't get tangled. Okay, this is the control room. So we don't go in these vehicles. Instead, we operate them from the ship. And so this is the very sophisticated control room. There's the pilot's head, navigator. Here's the co-pilot who's doing the camera sled. The pilot's doing the main vehicle, videographers, video clippers. And then here's a couple of us scientists. This is Dr. Parrish, and this is myself here. And so there were only 2 scientists on this cruise. And you may wonder, wow, okay, big ship, big expensive project, and they only got 2 scientists? Is that right? I mean, wow, boy, these guys are real elite. Well, it's not that, because as it turns out, there are many others who are exploring with us in real time. And I'll start off with describing what are called exploration command centers. These have super high-speed Internet 2 connections with 2-second delays here. And these are 2 rooms. This is set up in a NOAA center, and this is at the University of Hawaii. And so these people were watching and participating in the dive as well. And also there's aquariums in Hawaii that were actually watching the broadcast. They set up a viewing room inside the Maui Ocean Center Aquarium. And here's one of the scientists who couldn't get to an exploration command center. And this is Dr. Scott Franz. And he set up in his home his own sort of viewing station here. And scientists who want to participate are given a 7-second delay high-speed internet connection. So they can actually talk to the ship and interact and see what's going on with only 7 seconds delay. And even if you just use a regular internet connection with Internet 1 and a 30-second delay, like kids who are eating their breakfast in the morning, you're seeing it in real time. So how is that even possible? How can the ship's thousands of miles away? How is that even possible? Well, it's possible through the magic of telepresence. And this little animation that I borrowed again from NOAA shows you how it works. This is the video feed coming from the ROV. It goes up first to the camera sled, then it's sent up to the ship into a satellite dish. Satellite dish beams it up to a satellite. Satellite beams it down to a ground station, over to the Inner Space Center in Rhode Island, which then broadcasts it all over the world. And so anybody, anywhere on the planet that has an internet connection can see deep sea dives from the ships that are equipped with telepresence with a maximum of a 30-second delay. And that's about as real time as you can get. So that's a very, very cool technology. And when we were out on our cruises in 2015 through 2017, we would get millions of views from people all over the world participating and asking questions and so forth. And we did school interactions and you name it. Okay, so let's get to a couple memorable discoveries, and everybody has their own experience who's working in this field. I'm going to give you a few of my own personal ones. And this is perhaps the one that I think is #1 of all of them, and it's the spectacular communities that were discovered living thousands of meters below the surface. And the first one I'm going to mention are hydrothermal vents. I don't know much about them, so I'm just going to show one picture and a very brief video of them. But these were discovered first in 1977 by the guy who discovered the Titanic, Dr. Robert Ballard. And he found this off of the Galapagos, and since then they've found them all over the world. And these are super high heat vents of mineral rich water that's attracting a very large aggregation of unique animals around these. And this just shows you some of these animals that live exclusively around these vents. One of the things that I've been more involved in is finding these spectacular coral and sponge communities like these examples that are being shown from the musician seamounts. And these were first discovered in 2003 in the Hawaiian Islands, and now the hunt's on around the Pacific to find more of these, because the problem is that these communities are living right on manganese crust, right in the manganese crust mining depths. So it's a It's a little bit of a race going on right now to try to understand these communities, where to expect them, where you can predict them to occur. And with that, I'm going to show you some videos. Let's see here. This should work. Okay, I'm gonna have to escape just for a moment because I forgot one little key punch here. Hang on, I will be right back to you. I knew I was gonna mess this up. Okay, so let's try this again. That's better. Okay, first the hydrothermal vent. And some of these have sound and music to them. They were done by professional oceanographers and some don't.
So right now we're at a depth of 3,275 meters, looking at an incredible black smoker hydrothermal vent chimney. That black fluid coming out there is likely between 300 and 400 degrees centigrade. These ecosystems are literally islands or oases amongst what is, I mean, it's really cliche and the deep sea is definitely not a desert, but relatively islands of abundant fauna, islands of life in what is a usually desert-like deep sea floor. Oh, this is so cool. What, 27 meters high? 30 meters high.
That was a vent that we discovered off of the Mariana Islands. That was the voice of Dr. Diva Amon. And now I want to show you some high density communities, corals and sponge community video from around Hawaii.
By using the high resolution seafloor mapping data, we prospect almost for these high density communities because now we're getting a pretty good feel of what type of features they like to live on. So we look for the steep ridges, steep flanks, steep slopes, cones.
So the features that John was just talking about are important to accelerating currents. And more current means there's more food coming to our corals and sponges, and more food makes happy corals and sponges. They'll grow bigger, stronger, healthier. So this coral is taller than our ROV. That's pretty impressive because the ROV is way taller than me.
The forest has more ecological value and harbors more species than an individual tree does. That's the same way that these aggregations of corals or sponges act as hotspots of biological diversity in the deep sea. And if undisturbed, many of these can create habitats that can persist for hundreds and even thousands of years.
Check out the base on the hemicorallium. It is massive. That base only grows a millimeter or less per year. So you're seeing something that almost 8 inches across. That's well over 200 years old right there. They grow very slowly, and if someone were to come and harvest them, recovery of this community would take a very long time.
Everybody else watching should realize how lucky we are to see this huge density, this really high density of corals, because this is not a common sight. As far as I know, we're talking, on the order of 20 or so known communities like this one.
This area, the Musician Seamounts, probably has the most high density communities of any area that we've been in the last 3 years. I'm just astonished. Every single dive is coming up with communities that are different.
Okay, and that music, by the way, is because we are diving in the Musician seamounts that were named after famous composers like Beethoven seamount and Mozart and so forth. Okay, this is one of my favorite little clips. This was when we were off of Johnston Atoll.
Jeez.
You're right.
Talk about a Dr. Seuss like landscape. Wow.
Wow.
Look at this. This is amazing.
That
If we could just hold the scene for a moment.
Wow.
This is Attack of the Sponges here.
You wanted sponges, Chris.
Yeah, I got them. Yeah, that's, well, okay, I got them. Wow.
So the great thing about this that I love is the way they're all oriented directly into the current. This one looks like a Muppet.
This is why sometimes I think these sponges, when you come up against something like this, you think you're on a different planet. Just so strange.
Wow. It goes on and on, too. Every time we do these dives, all I can think about is, you know, this is the type of experience someone would have if they found like life on another planet. You know, everything's so alien to, at least for me, even though I've been doing it for 5 years, it's still like I'm on another planet when we're down here.
Yeah, and it's definitely the same for me as well, Pilot, because even though I work on these sponges, a scene like this is just extraordinary.
And I'll toss my hat in the ring too, as a person who studies echinoderms, which are even more bizarre. These things just stun me. Like a forest of the weird.
So how about on the West Coast? So a few weeks ago, the Nautilus was diving its ROV, the Hercules, off of, it's now down off of California. But I did some quick video clips while they're down off of the Channel Islands, and you can find really beautiful, there's no sound to it, but you can find really beautiful coral and sponge beds here on the West Coast as well. This is a little further out, but as you can see, very, very high density. These are all sponges, anemones. These are various species of deep sea corals. Right here, you've got sea stars, and they don't look much like your common sea stars. That one does. But these are called Brisingeids, a different type of sea star. But there's incredible wealth of deep sea animals. Here's some crabs coming in as well, right off of our West Coast as well. So these very high density communities are across the Pacific. They're not unique to Hawaii or the Central Pacific or something like that. Right, how about off of Washington? Well, I'm going to show you again, just a few weeks ago, a dive by the Nautilus and the Hercules off of Quinault Canyon. And, oops, oh, darn it. Sorry. Okay, here we go. I'm just gonna let this play, but in any case, these are bubblegum corals, and these are some sponges down here as well, and some anemones. Here's another type of a sponge as well. So there's a lot of sedimentation here into the canyon, so you don't have quite as lush communities here. But if you were to go further, which they haven't done much deeper diving further out, I'll bet you'd find some really spectacular corals down near the Cascadia margin, a little further out. Okay, so that's it. Now I gotta once again go back into my PowerPoint because I keep hitting the wrong button. Sorry about that. And now I want to just show you a little bit of video of strange animals, and hopefully we're not running out of time. But the first thing, just to set this up, is this is an animal we don't know. We think it's in a whole new family of tube anemone. And this is what a normal tube anemone looks like. This is going to be a new species. We've never been able to collect this, but they're called tube anemones because they secrete sort of a leathery tube that they dive into when disturbed. And one of the other characteristics about them is it has a central ring of tentacles right around the mouth, just like this guy does. So we do think this is a serianthid, but it's on a rock, it's not in sediment, and it doesn't have a tube, which is really weird. So keep that in mind. And then also I want to show you, this is called a feather star or a crinoid. And typically you see them on corals or on rocks sitting on the bottom, and they kind of filter the seawater and try to catch things out of the seawater. They're usually very sessile. And then here's a snail. It's called Gaza as well, and just commonplace snail. And so with that, I want to show you a couple videos where we get surprised by these animals. And here's the serianthid or tube anemone. We'll start with that. Stretch this out a bit. And I want you to watch and see what happens when we try to sample this.
It is detecting. Whoa! What is it doing?
Should I
Look at this.
let me know if you want me to zoom out
Okay, zoom out. Zoom out. Well, that was unexpected.
or full wide?
Yeah,
Do you want me to try to still collect it?
yeah, absolutely.
Gonna open the box.
But we didn't actually wind up collecting this thing. He evaded us. We got a little piece of his tentacle for genetic analysis, but this guy is unknown, and tube anemones aren't supposed to swim. So this guy is really odd, and this is where you just get surprised, and this is why we love working in this area. Now let's take a look at the feather star.
Now that's a treat.
Yeah, the first one we've seen on this trip on the move.
Well, they're normally disturbed, and I gather we disturbed him, and that's why he's swimming. Just shows you that they've got a defense mechanism here. They have a way to get away by literally swimming away. And if you don't know that they could do that, you'd never guess that they could swim.
Keep going with perfect.
Watch him settle down. And everything's calm again. He's in a good place once again.
And that's the way you normally see them. So now we know, of course, that quite a lot of them swim. And then I want to show you the snail. And this is, we call it the acrobatic snail.
So interesting.
So how is
They're
he
shooting
moving like that? What is he doing? It's not like, it doesn't seem he's pushing off with his foot.
All right. It's just flipping around.
So the acrobatic snail, that was a new one for me. I had never seen that before. And then I'm gonna, let's see if I don't mess this up. Hopefully I won't. Okay. Then I want to turn to octopuses here and sort of link this to Eleanor, the Port Townsend Marine Science Center octopus. This is some imagery that came out of the Marine Science Center, and it was in the PT Leader when they had released it, I guess. And anyway, that's kind of a normal sort of shallow octopus, but the deep sea octopuses don't look like that. We actually call the one that we see most commonly the Dumbo octopus because of these ear flaps on it. Grimpoteuthis is its scientific name. And then there's another one, we've only seen this twice ever, and both times off of Hawaii, and nobody else has documented it. It does not have these flaps. We have no idea how it moves, and it's going to be a whole new genus and perhaps even potential new family of octopus. And of course, we weren't able to collect it, and we wouldn't anyway. This is a pretty large animal, but all we could do is call him Casper for now, and hopefully someday we'll figure out what it is. But I want to show you how these guys move, as well as some fish. And we'll start with the Grimpoteuthis.
That rock has eyes.
Looks like a Dumbo octopus.
Beautiful animal.
Yeah, really incredible.
Looks similar to the character Dumbo, the elephant, when it's flying, swimming through the water column. You can see how it controls its propulsion with the fins behind its eyes. Is that a missing arm or maybe a regrowing arm?
Yeah, looks like it.
There might be some scarring there.
Looks like it may be an old individual.
This is really valuable footage. We know very little about the behavior of these cirrate octopods.
Okay, and then I want to show you a couple fish, and these will be the last couple of videos, and I'll just show you a few more pictures, and then that'll end the presentation. We can take some questions. But we call this the slinky fish. This is off of the Marianas.
The head, so they both wind up on the same side. And in flatfish, you have right-eyed flounders and left-eyed flounders. Now, this particular tonguefish has got the eyes on the left side, and so that's informative.
Thank you, Chris. I have to say, watching this guy move is just fascinating. One of the things that's been great about all of these dives is seeing this diversity of fishes and how they adapt to their environments.
Pretty fine movement.
This guy's just weird looking.
Okay, then perhaps my all-time favorite, and this was some video that was collected off the Nautilus in 2018. I was on that cruise, and it was in the northwestern Hawaiian Islands again, in the Papahanao-Mokuakea Marine National Monument. And this was just astonishing. Nobody had ever seen this type of fish in its environment before alive.
Take a look at that. What is that? Oh, wow.
Looks like a Muppet.
What are you?
What is
It's
that?
like a, huh. Oh, it's a fish.
Defensive.
In the water column.
That's a fish?
What?
What? Wow.
It looks like it.
Is it engorged or is it like that?
Is it mad?
Yeah.
Touch it.
Just
Look! Oh my god!
Look at that.
Wow!
Goodness.
Look at the
Oh my
face.
god!
It's kind of like googly eyes.
I think he ate
We
too much.
yeah.
What? He's full.
Wow.
Wow.
We really ticked him off.
Uh-oh.
Wow.
Whoa. What?
I thought it's like the gill arching. The gill.
Some kind of
What is
whoa.
it?
It just got so big.
It's all bladder.
Oh my god!
That's his defense. Like, let me
Oh,
blow
yeah.
up so I can show him how big I am.
Wow.
Yep, he's doing the shake.
What's a
Oh.
Oh my God.
Yes.
Is that a gopher eel?
Wow.
Yes.
So yeah, that is crazy.
That was awesome.
That was awesome. What a way to end the watch, right?
Bye.
Needless to say, when that was posted on the internet, it got millions of views. So I'm going to talk very briefly about some of the other things I find really fascinating about the deep sea. And these are relationships between different species. This is a type of coral called Metallogorgia melanotrichos. And there's a brittle star in the center of it. This is called Ophiocreus oedipus. And this is a cosmopolitan coral that's found in the Atlantic and the Pacific and everywhere. And whenever you see this coral, you always see the same species of brittle star, no other brittle star. How is that even possible? How do they coordinate to that degree? How do their reproductive cycles work so that they're so synced that because they don't live on their own. Very, very young Metallogorgia, you can sometimes see them without the brittle stars, but that's it. This is a sponge. The white part is, and initially we just thought these were hydroids growing all over the surface of it. But then we found out that this is actually a black coral. And the larger, more hard versions of black corals, of course, they make jewelry out of in some places in the world. It was unknown species at the time when we collected it. And just about a week ago, they described it. The paper came out and I was sent the paper itself. So now we have a name for this particular thing. But it's not hurting the sponge. The sponge is very, very healthy looking, and you very often find these sponges covered with this black coral. Arthropods and anemones and zoanthids are always really interesting. This is actually like an anemone, but it's a zoanthid, a little bit different type of cnidarian, and it's not on a shell. It kind of grows on the back of this crab. And again, you only see this crab with this cnidarian on its back, and you only see this cnidarian on this crab. You know, again, how do they coordinate this? Here's another crab, but instead of it attached to his back, he's carrying it in his hind legs. So there's the anemone. And again, whenever you see the anemone, a crab's carrying it. Whenever you see this crab, it's got its anemone. So How do they do that? I don't know, but it's pretty amazing. And we have a lot to learn about the relationships down there in the deep sea. And then I'm going to talk a little bit about feeding, and that's it. So there's quite a lot of animals that eat the corals down there, believe it or not. And sea stars are among the most voracious coral predators. And the way they do it, this is a sea star called Circeaster, is that it inverts its stomach, and it actually wraps its stomach around the branch and digests the tissue off of the branches. So it's already eaten all of these branches here, and now it's working on this one here, and we'll probably go right to the end. But it's a rather wild form of predation, if you will. This is a sea slug, believe it or not, and he has evolved to actually wind up and crawl up on this bamboo coral here, and he's up on the top and he's eating it polyp by polyp. There's its mouth, and he'll just keep working his way up very, very slowly, and you don't see these things on the ground. And once they find their coral, they're probably good for life because it takes them a long time to eat all the polyps off of a coral. And then when we first saw this, certainly when I first saw this, I had assumed that the coral actually caught a drifting little tiny jellyfish, and it's actually just the reverse. This is a minuscule jellyfish that is a predator on corals, and it lands on the corals. Its tentacles, it only has two. It uses it to hook onto the coral to stay in place, and then it starts consuming that coral polyp by polyp, and it probably takes them quite a long time to eat each polyp. But that was a startler for me. I didn't know there was any type of animal that did that whatsoever. This is because we're close to Halloween. I had to show you a sea spider here, and that's a sea spider, and he's got his proboscis right inside of an anemone, and he's basically sucking out the innards of this anemone, sort of Dracula style, if you will. So this poor anemone is not long for this world, and that's what these guys do. They get up on a coral, they find their anemones, and then that anemone is history if he's discovered. Pretty disgusting, I think, but anyway. Here's an animal, it's called Yoda. It was named appropriately, in my mind at least. But this animal goes around and it just starts engulfing sand. And as the sand passes through this long digestive system, I assume enzymes and other things go to work on the sand and get organic material out of it, all the way down to the end of its tail. And then it poops it out and leaves this long cylindrical tail as well. But they're just gorgeous animals down there. And it's we don't see them very often, but it's a real treat. And this guy was really deep. I think he was 3,000 plus meters down. And then finally, this is my last picture here. And this is actually a sponge that was first described off of the West Coast in the Monterey Bay Aquarium Research Institute's study site, Monterey Canyon, if I'm not mistaken. And it's called Chondrocladia lyra for the lyrate structure of it. This is a predatory sponge. So it doesn't look anything like your big, massive globular sponges. And this thing catches things, bugs, and bugs I call them, but arthropods, crustaceans, and other things that come by in the water and eats them that way. So very cool. That's the way they figured out how to survive down here. So that's all I got for you today. Hopefully you have enough time for questions. If you too want to watch live and see deep water dives, here's some websites that you can do: the Nautilus, the Okeanos Explorer, the Falkor, and the Schmidt Ocean Institute as well. And then here, if you want to look at some pictures yourself, there's 5,000 pictures that my lab back in Hawaii, we created all these pictures for the Okeanos Explorer for their website. And you can download them and see a lot of the animals that we've been seeing down underwater. And I also want to thank everybody, the Port Townsend Marine Science Center, as well as these NOAA offices here, the Deep Sea Coral Research and Technology Program, Schmidt, University of Hawaii. A lot of people are involved in deep sea research. And with that, I'm done, and I'm going to turn it over to Janine, I believe, if I can figure out how to do that. So Janine, are you there?
I am here. I'm coming back.
Okay, I'm gonna stop sharing, right? Or do I just leave it?
Yeah.
leave your slide, Dr. Kelley.
Excuse me?
You can leave up your slide.
Oh, I'm leaving it. Well, I'm leaving it up. Oh, so am I?
It up is a good idea, so that people can copy it down. And we'll also have this on the website so that people can look. Okay. And all right. So it doesn't look like my video's on, but you don't need my video. You just need the handsome face of Professor Kelley and our questions. We've got some really good questions. And if people want to continue to put them in the chat, we can track the questions. The first question is from Vuhuya, and they would like to know regarding the mining, has it already been, there's already been mining between Hawaii and Society Islands, is that true?
There's been some test mining somewhere off of Japan. They've done some test commercial mining down there. In the Cook Islands, they're exploring the possibility of doing nodule mining in the Cook Islands. And then there was an outfit that was going to be doing some mining down in, I think it was off of Papua New Guinea, but I think they ran out of money when they were developing all of their machinery and so forth. But I'm telling you that even though there's not a whole lot going on right now, it's coming. And there's a lot of people working on this to make it happen. It's very challenging technologically because you've got to get big machines down thousands of meters below the surface and be able to pump this stuff up to a ship. But it's coming.
Well, I know this is a particular passion of yours, is regulations around that. And as I understand it, that's going to be the topic of the deep dive, a new feature for the Future of Oceans lecture series tomorrow night. And I think there are 5 spaces left in that deep dive, which is a more and very appropriate name for Dr. Kelley, but it is a bit more of a conversation. So it'll be only 20 people, and that's tomorrow night, starts at 6:30, and you do need to pre-register, and it is $5 to participate, and it's a new feature of our Future of Oceans lecture series. So a lot more about that topic tomorrow night, if you can make it. Another question. Hello, Dr. Kelley. Are you a diver? And if so, have you done any blackwater diving in Hawaii as a means of further discovery of deep water marine life? Thanks, Reginald Brown.
Okay, well, I was a diver. I don't do that much anymore. I actually was on a hydrolab. I saturated in the hydrolab undersea habitat in the Caribbean way back in my early 20s. And I did a lot of diving in Hawaii. The deepest I've ever been is about 150 feet down. So no, I'm not a technical diver, but I have done blackwater diving in a reservoir up on the island of Oahu when I was working on a catfish project, and it was totally dark and black at 30 feet down. And we had to do all of our work by feel, replacing instruments by using guidelines and following guidelines to replace our instruments. And it was really weird. It was sort of like being back in the womb or something. It was a strange experience.
Wow.
And lights didn't work. The dive lights they would shine about 6 inches in front of you. You couldn't see anything. So it was all by feel. It was a wild experience.
Wow. Wow. Next question is from Paul Eisenhart, and he wants to know how large can the tube anemone get that you were showing in the presentation?
So
how large have you seen?
So that tube anemone, it was probably about 10 times as big as a normal tube anemone that I've seen down there. I mean, it was enormous, and we saw it on a couple of occasions, and we thought that it was just a variety of a big anemone that we know about in the family Actinostolidae, which is fairly common down there, until we got a good look at one of them, and then we saw that inner ring of tentacles and going, no, this is not an anemone. This is a tube anemone. And anyway, that thing was probably foot and a half across with the tentacles, and a normal tube anemone is about maybe 1 to 2 fingers. That's about it. So
Wow.
we're going to find one. We're going back up to the northwestern Hawaiian Islands next year, and that's high on our wish list to try to get a specimen of that.
Any ideas why it's so much larger in the deep sea?
No idea, because there's small tube anemones in the deep sea as well. This is just some unique species that we've just met in the last few years down there that we did not know exist. And sorry, I keep looking over at yours. I've got the the zoom on one monitor. I should be looking straight ahead, but yeah, we just have no idea. It's just a new species.
Wow.
And
Wow. So, and Noreen Parks is one of our major inquiring minds, and she has multiple questions. First of all, did you dive on Loihi? Loihi. Sorry, I need to spend more time in Hawaii. Maybe you can hook us up. Loihi.
Yes, I personally have not dove on Loihi, but the institute, the Hawaii Undersea Research Institute that I worked for quite a long time, they did submersible dives on Loihi and had quite a few adventures. I'm going to say this, and I hope I don't offend anybody, but I kind of found Loihi to be a little bit boring. It sort of trickles out sort of hot water, and there's not that many animals around. So for a biologist, it's not all that interesting, but a geologist love it because there's a lot of activity, brand new pillow lavas, it's growing, it's going to be a new island. But anyway.
Got it. So this is also from Noreen. What areas of the floor did your mapping efforts focus on?
Well, in 2014, I was actually given 72 days to lead a cruise on the Falkor to map the northern half of the northwestern Hawaiian Islands in the Papahanaumokuakea Marine National Monument. And that's what we did. We did a lot of mapping there. I've done a lot of mapping in shallower depths around the Oahu and the other main islands, and I've mapped down in some other seamounts elsewhere. And then as part of all of our exploration cruises on the Okeanos Explorer and on the Nautilus, mapping is always the first thing you do because you can't see the structure and the topography well enough to put your vehicle down safely until you map. And so there's mapping always going on with every cruise that I've been on.
Wow. And were geodes a frequent feature? Another intriguing feature, also from Noreen, the inquiring mind.
Geos are fascinating to me, just because you're seeing something that's thousands of meters below the surface, and you know that it has been above the surface and was an island 50, 100 million years ago. And typically what you see is you see a lot of corals right around the rim, and then fewer up on the flat top, which tends to be more sedimented, where a lot of sediment just sort of accumulates. And then the slopes of these geodes have got a lot of animals that are very rocky. But they're just, I don't know, they just are really, really interesting seamounts, and there's many, many of them in the Pacific.
Great. And I have a question. In all of our conversations, I've been wanting to ask you this for a long time. I understand there's a glass sponge colony or colonies in the Canadian waters of the Salish Sea up in the Georgia Strait. Do you have any interest in exploring that now that you're a member of Cascadia, or more local?
Yeah, so actually, I'm on a committee right now where I'm helping to develop a West Coast animal guide, which is going to include a lot of sponges on it. I was already sent a bunch of photographs of sponges that were collected off of California, not the specimens themselves, but photographs that I helped identify. And then I think very shortly, I'm going to be receiving some more specimens that were collected off of Washington, in Oregon, in California to work on, because I'm a nerd enough to actually have set up a lab in my basement to look at sponges. And so I'm trying to help out. I'm not a real hardcore taxonomist that's describing a lot of new species, but I really enjoy helping out and trying to identify things.
That's great. That is great. So I'm guessing that people will have more questions. And if you do have more questions, we'd like to encourage you to send them to info@ptmsc.org, and we can pass them on to Dr. Kelley. And I'd like to remind people about tomorrow night's program, Deeper Dive. It starts at 6:30 with Chris Kelley, and there's 5 more spots left. And you can email Gabrielle Sanchez at gsanchez with a Z at ptmsc.org for that registration link. And so just one more time, and I will try this again. I don't know if it worked the last time, but here we go. Oh, maybe not. Oh, I just pretend that you're hearing huge amounts of applause, Dr. Kelley, because I throughout the program, I know that everybody's going, wow, that's amazing. I could hear it throughout the neighborhood. So thank you, and applause, applause, applause. And I know that everyone out there is just so appreciates what you are doing and have done, and that you're now a neighbor. So pretty exciting. So thank you so much.
Well, thank you so much for giving me the opportunity. I really enjoyed it.
Great. And I'm sure we're going to keep you active and busy and very engaged with the Marine Science Center.
Terrific.
So thank you. And next month, we look forward to you joining us on December 13th for a program with Betsy Peabody, the Executive Director of Puget Sound Restoration Fund. And it's going to be an immersion in kelp, immersion in the world of kelp. And in the meantime, if you haven't heard, we have exhibits open by reservation on Friday, Saturday, and Sunday afternoons, both the museum and the aquarium, and we'd love to see you. And fear not, even in time of COVID, the Port Townsend Marine Science Center holiday sale will go on because of our intrepid volunteers. So that will be the weekend after Thanksgiving in the gift shop, and we have all COVID safe protocols for those of you who want to join us. And I am just extremely grateful for the team. We are, as we started this crazy time in March, we committed that we were going to be stronger than ever, and we indeed are, and that is because of our extraordinary community, and in particular you, Dr. Kelley. Thank you. Thanks to one and all, and we will see you soon. Stay safe. Thank you.
Thank you, everyone.
Bye.
Bye.